Okay, so we're going to take a look at limiting reactants, meaning there's just not enough of something. When we did the s'mores analogy, we looked at it and we already identified limiting reactants. It's whatever we ran out of first, whether it's graham crackers or the chocolate pieces or the marshmallows, whatever we ran out of was our limiting reactant. And our other thing that was left over was called in excess or extra. We had always assumed that there was enough of the other chemical for the reaction to complete itself. So any kind of reaction that we were taking place, we were assuming that if we were doing a reactant to figure out how much product, if it reacted with something else, we assumed that we had enough of the other thing. And you should continue to assume that unless you're told otherwise. But in a limiting reactant problem, we'll be given information on two reactants, and one of them will run out. One of them will get used up. This is similar to when we ran out of graham crackers or marshmallows or chocolate pieces, like I was saying. So what does a problem like this look like? It says something like this. You're given two amounts to start with. So it says 17.82 grams of sodium hydroxide reacts with 15.40 grams of phosphoric acid to give sodium phosphate in water. Okay, how many grams of sodium phosphate is formed? Which reactant is limiting? So the first thing I'd like you to do is to pause the video and to write the balanced equation for the reaction that's shown above. Okay, is that what you got? Hopefully that's what you got. So that's our balanced equation. I wrote water as HOH to make it simpler to balance without hydroxide, but you could also have written it as H2O. So the problem told me that I had 17.82 grams of sodium hydroxide and I have 15.40 grams of phosphoric acid. How many grams of sodium phosphate is formed? So this should be your key to the limiting reactant problem. So remember, I'm trying to teach you how to recognize what type of problem it is. A limiting reactant problem will always be given with two amounts of starting materials, or two amounts to compare to. Okay, so we have to figure out one of these will be used up first. It's either our graham crackers or our chocolate pieces. One of these will get used up first. We don't know which one it is. The only way we can do that, and it's not any harder than what we've done, is I need to do stoichiometry from there to there, and then I also need to do stoichiometry from there to there. So I need to do one problem using sodium hydroxide, and I need to do one problem using phosphoric acid. So let's get a different color here. So let's start with I'll make that the blue, the purple, the sodium hydroxide. So I'm just going to do 17.82 grams of NaOH. Get rid of grams of NaOH. Convert to moles of NaOH. I'm getting rid of moles of NaOH, and I'm converting to moles of Na3PO4. I'm getting rid of moles of Na3PO4, and I'm converting to grams of Na3PO4. These ones are always 1 and 1. This comes from my balanced reaction. That's my big switch in there. So Na3PO4 has a 1 in front of it. NaOH has a 3 in front of it. I have to do my gram formula weight, so I have 40.01. And my other gram formula weight is 164.00. And when I solve that problem, I get 24.30 grams of Na3PO4. I'm going to go ahead and do the other problem. So I'll set it up the same way. 15.40 grams of H3PO4. Grams of H3PO4. Moles of H3PO4. Moles of H3PO4. Moles of Na3PO4. Moles of Na3PO4, and grams of Na3PO4. 1 and 1. I look up here. Na3PO4 is still a 1. H3PO4 is also a 1. My gram formula weight is the same, 164. My gram formula weight here is 98.03. I solve this whole problem and I get 25.76 grams of Na3PO4. How do I know which one is limiting? Well, whatever one produces the smaller amount is limiting. So if I look at my two answers, this is the smaller amount produced. 24.30 is smaller than 25. And so that is my answer. So how many grams of sodium phosphate is formed? This is done, 24.30 grams of Na3PO4. Which reactant is limiting? I trace back over here. Whatever one I ran out of first is my limiting reactant, so it's NaOH. My one that's in excess is the H3PO4. We can do this the same way we did the example with the s'mores. So identify the limiting reactant. In this case, it's a 1-to-1 ratio. So if I have 100 atoms and 100 molecules, it's going to react perfect. And so we could either say both. We could say both, or we could say neither. So both or neither. Or we could say that we call this the stoichiometric amount. If I have 150 of this and 100 of this, well, I'm going to run out of the one that's less. I'm going to run out of I2. If I have 200 atoms of Mg and 300 molecules of I2, I'm going to run out of, in this case, Mg. But remember, it's a 1-to-1 ratio. If I look at moles, if I have 0.16 and 0.25, I'm going to run out of the one with the smaller number of moles. So again, that's going to be Mg. If I have exactly the same amount, again, we're going to call this the stoichiometric amount, meaning it's the perfect amount to react perfectly. So I'll react all of this and have none of my reactants left. If I have 0.12 moles and 0.08 moles, it's going to be the least. It's going to be the I2. And if I have 1 gram and 2 grams, don't get tricked into just picking the 1 grams. We would need to convert to moles. Okay, let's try one more problem that we have here. So 64.81 grams of silver nitrate and 92.67 grams of potassium bromide. How many grams of silver bromide is formed? Which reactant is limiting? Which reactant is in excess? I'm going to ask you to pause your video and solve this on your own. If you can do this, this is a perfect test for getting ready for your exam. So I'm going to ask that you do that. Okay, so take a look at what has shown up here to solve. I converted 64.81 grams of silver nitrate, and I solved and got 71.64 grams of silver bromide. I took the potassium bromide, and I got 146.2 grams of silver bromide. If you look at this, this is my smaller one. So that's how many grams of silver bromide is formed, so 71.64 grams. And my limiting reactant, I go back to the reactants. Okay, silver nitrate is my limiting one, so AgNO3. And which one is in excess is obviously the other one, so that's going to be KBr. I'm going to show you one more thing because this is the last part of this unit. It's called actual and theoretical yield. So what happens is when we do problems, when we do the labs really in chemistry, is theoretically this is what we should get. But chemistry is not perfect, so it doesn't come out to be the perfect amount. So we talk about something called a percent yield. The percent yield is equal to the actual amount that you get. So the actual yield, this is from the lab, over the theoretical yield, which is what you get from stoichiometry problems. And you multiply it by 100. So this told us the actual yield is 54.77 grams. The theoretical yield is what we got in the problem, which is the 71.64 grams. And we multiply that by 100. And so it tells us that our percent yield is 76.45%. And that's the last new thing for this unit.